Hello everyone, this is Mr. Harper. So we are going to start today our discussion on radiation. I know we actually had notes on these today in class, so this is going to be a review and I'm going to try to fly through it really quickly. Remember that radiation is the transfer of energy by electromagnetic waves. Electromagnetic waves can damage living tissue, and that's why that we need to be careful around them. And there is a spectrum of electromagnetic waves. They are light waves, although we cannot see all forms of light. And let's take a look at this next picture and we'll see some of the things that we cannot see. So as you look at this picture, electromagnetic waves start at low energy, long wavelength radio waves, move up to the microwaves, to the infrared waves, to the visible light, and then the ultraviolet, and then the X-rays and the gammas. The visible light and some of the ultraviolet and some of the infrared are the only part of that spectrum that we can see with our eyes. And you notice, like I said, the waves are getting shorter in wavelength as you move left to right. You notice the amplitude, the height of the wave is staying the same. All the amplitude can vary, and it does, but right now they're all the same. And the amount of energy that the waves carry is going up as you move from left to right. Here's another way of looking at it. You have the radio waves, FM and AM, split out here on this end, and you're moving all the way up here to the gamma waves. Here's the X-rays. The visible light is this piece, once again, you can see, and it can be split out into the Roy G. Biv, red, orange, yellow, green, blue, and you could have indigo for the eye there, and violet. Those are the parts, the waves that we can see, and the lowest energy wave is red, the highest energy is violet, moving left to right here. Longest wavelength here, shortest wavelength there. Waves, electromagnetic waves, you can think of them traveling like an ocean wave, up and down and up and down. The top of the wave is called the crest. The bottom of the wave is called the trough. The distance until it repeats itself is called the wavelength. So here it is from the top all the way down to the trough, all the way back up to the next top. And then the wave would simply repeat itself. That's a wavelength. You could also go from trough, bottom, way over here, to here. That would be a wavelength. Or you could start like right here and go up and down and back to the exact same spot again right about in here. That's a wavelength too. It's a distance. How far does the wave travel? Meters, inches, feet, miles, that kind of thing. Waves start at a center point and travel out in a circle from that, and as they travel out in that circle, they get weaker and weaker and weaker because that energy is in a bigger area. So right here, this wave would be pretty big, pretty tall in amplitude, and here the wave is getting smaller because all of the energy that was in this smaller wave in size is now in a bigger wave in size. It's the same amount of energy, just more spread out. By the time you get all the way out here, the wave is even smaller in amplitude, same amount of energy that wave is carrying, but it's in a bigger area now, so you have a smaller wave as a result of that. And at each point it's felt less because it's smaller amplitude. The amount of energy the wave carries is determined by its wavelength. So here's a short wavelength, a medium, and a long wavelength. The longer they are, the less energy. And we talked about in class how this wave would hit you very frequently. In the same amount of time, this wave would hit you 1, 2, 3, 4 times. This one would hit you 1, 2, 3, 4, 5, 6 times, but this one would hit you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. You notice that the amplitude of these three waves is the same, which means the amount of energy each wave carries is the same, but the frequency at which the wave hits you from here to here to here is different. Frequency is the highest here, the lowest here. And the wavelength, once again, the distance between two waves, if you're talking about like a TV wave, it's about 6 feet long. Microwaves generated by microwave ovens are about 2.5 inches long, while an X-ray is a billionth of an inch long. So the difference in size, and that shorter the wave is, the more energy it carries. Frequency is the number, how many times the wave repeats itself in 1 second. That's in a special unit called a hertz. These waves would not repeat themselves as often because they're longer waves. So the frequency, as you go from here to here is getting higher. Low frequency, high frequency. Long wavelength, short wavelength. As the wavelength gets smaller, the frequency gets larger. As the wavelength gets longer and the number gets bigger, the frequency gets smaller. They're inverses of each other. We talked about hard and soft radiation. Soft radiation has weak penetrating power. Hard radiation has strong penetrating power. X-ray waves and gamma waves are considered to be hard radiation waves. Everything below that, from ultraviolet all the way down to radio waves, have soft penetrating power and are called soft radiation, or weak penetrating power. The last thing we talked about is this, the radiograph. The radiograph is, what would commonly be called an X-ray. Remember I told you that X-ray waves have the ability to go right through your body except for through bone or teeth. Those are too hard of a substance. X-rays can't go through them. So the film is placed behind you. The X-ray machine is in front of you. You are in between the two. As X-rays waves hit your body, they go straight through and hit the film. Everywhere where it hits the film turns black. The areas that show up white on the X-ray machine are where the X-ray waves hit the bone, could not go through, and bounced back off. And that means the film was not exposed and the film stays light. So this area right here, this brightest area of white, this is the hardest part of the bone, or the densest part of the bone, the thickest. Where this area here, it's thinner. If you saw a black line right here, that would indicate that that bone was broken at that point, because the X-ray waves went straight through the crack and it showed up on the X-ray, on the radiograph, or the X-ray was what it would be commonly called. So we've started our little introduction here to X-ray waves and radiation. Remember the electromagnetic spectrum. The longer the wave, the lower the energy. The higher the wave, the shorter the wave, the higher the energy. We'll talk more next time.